students, welcome to this session where you will be performing the 8th experiment in the DST lab. So the experiment is designing an asynchronous counter using flip-flops. So here I'll try to explain how to realize an asynchronous up counter using JK flip-flops. So this is our objective for this particular session. So we are going to realize a 4-bit asynchronous counter using JK flip-flops. So before performing the experiment, you need to have an idea of how a JK flip-flop operates, what is meant by toggling, and how a clock can be applied to the flip-flops, and what is the effect of that clock on the flip-flop output. What are the different types of triggerings available, and when is the output of the flip-flop affected because of this particular clock signal. You should also know what is the difference between synchronous and asynchronous circuits and their effects on the outputs of the flip-flops. So I have provided here some reference points related to asynchronous counters, how they can be designed, and how you can realize a mod counter using asynchronous counters, and how it is being used for frequency division operation. So coming to the implementation, let us see first what is the apparatus required. So for any experiment, we need components and equipment both. So in components, since we are implementing the counter using the JK flip-flop, you need the JK flip-flop IC the number is 7473. Then you need input switch to apply clock signal, and you need output LEDs to observe the counter output, and protective resistors. Then coming to the equipment, you need a power supply and breadboard to make all the connections, and then connecting wires. And this is the pin diagram of the IC which you are going to use in this particular experiment. And this is the circuit diagram for a 4-bit up counter. So you are using 4 JK flip-flops here. Since each IC is going to have 2 JK flip-flops in it, we'll be using 2 7473 ICs here. Please follow the procedure which is given here. Make all the connections according to this procedure. Avoid any loose contacts. So once all the connections are done, you should be able to observe the counter output by varying your clock signal. This is the experimental setup in the Tinkercad environment. This is provided here only for your reference. So you can modify the placement of the components and everything. So I have highlighted all the components which are being used here. And this is the truth table which you need to verify. So I have already mentioned what is the count here. So Q3, which will be your MSB, and Q0, which will be your LSB. So if you observe, the count keeps increasing from 0, 1, 2. So this is how your count will be increasing, and you will count till 15. And finally, after 15, the count should again be reset back to 0. So this is how your counter 4-bit counter should work. Now let us learn how to simulate the experiment using Tinkercad software. So once you have moved to Tinkercad software, so this is, I have already shown this experimental setup. Now let us start simulating this particular experiment. So when I am simulating this, so I have already mentioned this is the dip switch through which I am applying clock signal. Now since the circuit we have developed is a negative edge triggered counter, you need to apply a negative, you need to get a negative edge on the clock. That means, so here through switch 2, I'll just switch it on and off, which gives me a negative edge. And you can observe the count here. So now it is counting the first pulse. Now if I keep switching it on and off, second pulse, third, fourth, please look at the LEDs. So this is how count, it is working as a counter. It is incrementing the counts, and it will do that till it reaches the maximum count of 15. So once it reaches the maximum count of 15, it will again reset itself to 0. So this is how you can perform the experiment in Tinkercad. Please make all the necessary connections, and then you need to verify your output. So coming back to the result, what we have done. So what we have done is we have realized a 4-bit asynchronous counter using JK flip-flops and verified its functionality. And now you need to perform this assignment. You have to design a 4-bit asynchronous down counter using JK flip-flops. So you need to understand what is the modification that needs to be done to the up counter circuit in order to make it work as a down counter. So here I have given certain Viva questions which will be asked in your interviews, and also they will be helpful for your placements and your gate exams. So thank you for attending this particular session.